All right, here we go. Question 39 from our Calculus 1, homework number 1 in WebAssign. It says if the symbol, and this looks kind of like double brackets to me, denotes the greatest integer function defined in this section, it says evaluate the following. If an answer does not exist, enter D in E. And so in order to evaluate these limits of the greatest integer function, one of the easiest ways to do that is going to be to sketch a quick graph of the greatest integer function. So here in our scratch work, I've got a coordinate system pulled up, and we're going to mark off a few x's here to the right, 1, 2, 3, and 4. And then same going up for the y-axis, 1, 2, 3, and 4. And here's what the greatest integer function says. It says, given any x value, if you eliminate the decimal part, that is going to be your y coordinate. So 0 would be a point on the graph, and then any decimal value between 0 and 1, if we eliminate the decimal part, would give us a value of 0. So the first part of the graph looks like a line, a horizontal line, all the way up to 1. And as soon as you get to 1, then the greatest integer at that point would be 1. So the graph jumps up to 1 at 1. And it's going to stay at a height of 1 until it gets to 2. Again, if you consider a number like 1.5 for x, if you eliminate the decimal part, then that gives you a y value of 1. And so really what we get in a sense here is we get something that's referred to as the step function, because it looks like steps. So at 2, again, the greatest integer at 2 is 2, but then any decimal value 2 point whatever is going to just be 2 until you get to 3, where it jumps up to 3, and then so on and so forth. Now, going into the negatives, this one's a little less intuitive, where you're going to have an open circle at 0, down at -1, and then -1 would be -1. Any decimal value, say -0.5, the greatest integer there is going to be -1 to continue the step pattern. And so again, we can rinse and repeat here, creating more steps as we go back to the negatives. So our first limit here that they want to calculate is the limit as x approaches -6 from the right, okay? So let's say we're looking at the limit as x approaches -2 from the right of this function. And we can see here where x is -2, if I'm approaching from the right, I'm going to be at a height of -2. So limits as you approach negative numbers from the right are simply going to be that value. And so this limit here would be -6. But as you approach -6, here this doesn't specify from the left or right. This next problem says just -6. Again, if we look at our previous example here and we say, well, what happens if we approach -2? From either side, you can see you're going to be on different steps. And that limit there is going to be does not exist, because as you approach -2, the pieces don't come together. They don't approach the same y value. So this one is does not exist. Next, part 3, we're looking at the limit as x approaches -6.3. Notice it doesn't say from the left or right. But that's okay, because -6.3 would be mid-tread. If you understand what that means, we're going to be on a particular step. And so again, if we look at what we have in our graph, if we look at as x approaches -2.3, that's going to be a number right here. That's going to be less than -2, which is going to take us down to this step, which is at -3. So any negative decimal value, you could say that it's going to round down because you're going to be on the lower step. And so this limit here would be -7. If you go past -6 to the left, you're going to be on the next lower tread, which here would be at -7. In the next part, part B, this is more of a concept question to see if we understand the concept. It says if n is an integer, evaluate each limit. And so if we pull up our graph for reference, first we want to know if we take the limit of any integer value from the left, what is the limit going to be? Well, let's say we look at an example where we say the limit as x approaches 2 from the left of this function. So here, if we approach 2 from the left, we're going to be on this step that's at a height of 1. So in that case, our n that we're approaching produces a value that is 1 less than it. And does that hold true for the other integers? Well, let's look at 3. So now if we approach 3 from the left, again, we're going to be on this step that's at a height of 2. So it appears that for any n, any integer value approaching from the left, the y value that you're approaching is always going to be 1 less than n. And so we would say that that is n minus 1. And then we want to look at approaching from the right. So again, if we switch this back and say, what happens if we approach 2 from the right? That would be coming in on this step here. Approaching 2 from the right means that we're going to be on the step that is at a height of 2. And if we switch that to 3, approaching 3 from the right means we're going to be on this step, which is at a height of 3. So in this case, approaching from the right, it appears that whatever your n is that you're approaching, you're going to be at that height. And so this one would be n. And lastly, for part C, it says, for what values of a does the limit of the greatest integer function exist? Looking back at our graph, remember we said that at the integer values, say 1, 2, 3, or -1, -2, -3, those integers are where you transition from one step to the next. And so those are not going to exist. But any x value that's a decimal, in other words, any non-integer value, the limit, the overall limit will exist, because as you approach from either side, you're going to be on the same step. So what we need to choose is the limit exists where a is not an integer. The limit exists for all non-integer values of a. And then we're going to click submit and see how we did. And scrolling down, it appears that we've got green check marks across the board. And I guess that's going to do it for this particular problem. So if you have any questions or comments about anything covered in this video, please feel free to leave those in the comment section below, or you can text me. And thanks for watching.